The BIM stands for Building Information Modeling, and basically what it is three-dimensional modeling with computer software for buildings.
Well, this is BIM, and it's a digital representation of built space. So everything that is going to be built and attached to the building, we put into the models, either in a full three-dimensional representation or in some cases a two-dimensional representation. We use BIM primarily for two things: visualization and coordination. The visualization is for the design team, for the client, and for the contractors or other people who are looking at the project.
A huge advantage of BIM would be able to draw this on 3 dimensions on some of the auto sketch programs that are out there, so that we could actually take a look at 3D on the computer, rotate around it, look at it from different angles. The mechanical, electrical, and plumbing is squeezed up so tightly above the ceilings and into chases throughout the buildings, which are shafts throughout the entire building, that it's got to be down to the quarter of an inch to make sure everything fits in there.
We were looking earlier and found some cases where we needed a little bit more coordination, so I'll show you take you through really quickly through a process that we go through frequently. I'm looking at the underside of the second floor ceiling, and as I was looking around the outside edge of the building, I saw something that seemed a little out of place here. And if I select it, I find that it's a steel beam. When I go to a three-dimensional view, I can zoom in, and you can just start to see, let the computer refresh here, there's my steel beam that's below my ceiling. And I say, oh, I've got a problem now, so I'm going to sort of zoom around. Can't really tell exactly how low it is below the ceiling, but I know that it sticks out. So I can go back to my previous views, and I can cut some sections and other things that will then tell me how much that beam is below the ceiling. I can then take snapshots of that. I can send it to my structural engineer and say, I've got a steel beam. It's popping out below my ceiling. What can you do about it? He emails me back and says, guess what? We can cut the underside of that beam, and therefore it won't come through the ceiling.
That level of detail is so important. Now, for years we've always done this with 2 dimensions, and we get it 95% correct that way. 3 dimensions adds that another level of capabilities to try to find out any clashes. You find those problems earlier, which we are doing now, solving them now so that they don't manufacture or they start the construction and then have to come up with a workaround in the field later on.